Hi guys, Dr. Tears here again. Gonna try to solve some of the problems from the review. This is actually number 6 from the review, and the problem says a ray in air is incident on a glass plate whose index of refraction is 1.42. The angle of refraction is 1/2 the angle of reflection. So this angle here, beta, is actually 1/2 of this thing, half of this thing. And they're asking you, what is the angle of refraction? It's closer to what? So the first thing we're going to do here is use Snell's law. You remember Snell's law says the index of reflection, sine of the angle of reflection, is going to be equal to the index of refraction, sine of the angle of refraction. Perfect. Great. This is something we need. But also, here's the thing. We actually have the index of refraction and index of reflection. The index, yeah, you have both index, because here it says it's air, and air is equal to 1. Well, you can barely see that one. And this one is glass, which is equal to 1.42. Great. Aha. But we don't know the angles, and both are unknown. But they're telling us here that the angle of refraction is half of the angle of reflection. So the incident is equal to what? The angle incident is equal to 2 times the angle of refraction. Or the way that I say it is actually that the angle of incident is equal, the angle of refraction is half of the angle of incident. Yeah, I wrote it here backward, but this is actually the equation. The reason why I wrote it backward is because I want this equation. Remember, we have 2 unknowns here in terms of the angles. And it's actually pretty difficult to solve this problem if you have 2 unknowns. But what if you can turn this angle into, well, the same type of angle? What if you have the same angles there, only one unknown? That would be great. And actually, in this case, since we're working for the angle of refraction, this is precisely the one we want. So this equation, this Snell's law, is going to change a little bit, and it's going to look something like this. Ni sine of 2 times the angle of refraction is equal to Nr sine of refraction. And remember, yes, it is. This is half of this one. This one is twice of this one. There's another way you can see it. Now, great. Now we have only one angle, only one unknown, because we know the index of refractions are defined. Well, it was 1 and 1.42, and we only have one angle, one unknown. But hey guys, be careful. Don't go here and cancel this thing and then put a 2 there, because that doesn't make any sense. Okay, this doesn't cancel that easily. You need to do, in order to cancel these angles here and have only one expression to have the sine of the angle, you need to use trigonometric identity. And that one, if you all, most of you took pre-calculus with me and calculus, you remember this one, the one that it says sine of 2 alpha. This is equal to what? 2 times sine of alpha cosine of alpha. This is the trigonometric identity that we're going to use. Why is that? Because then this one that it says sine of 2r is equal to what? 2 times sine of r, theta r, well, theta r, I should put it here, I'm sorry about that, cosine of theta r. And now, if I put this expression in here, we will have here, look, this is the, I'm going to rewrite this equation again. I'm going to put Ni sine of 2 theta r is equal to Nr sine of theta r. Now I'm going to make the substitution. This thing, which is here, I'm going to put it here, right? So this one is going to be Ni times 2, there's a 2, sine of theta r times cosine of theta r equal to Nr sine of theta r. And now you can see that this sine of theta r and this sine of theta r cancel. Perfect. Let me move this a little bit up. And what else? Well, we have here is going to be, well, we have a 2, so it's going to be basically 2 Ni cosine of theta r is equal to Nr. because the sine of theta r and sine theta r cancel. Solving for the angle, remember this is cosine. Solving for the angle, we divide everybody by 2 and I, so we will have cosine of theta r is equal to nr divided by 2 and I. And now in order to find the angle, we apply what? Apply cosine inverse both sides. Applying cosine inverse both sides, we have a cosine inverse of cosine of theta r is equal to cosine inverse of nr divided by 2 ni. So cosine inverse of cosine of r is going to be theta r is going to be equal to cosine inverse of nr divided by 2 times ni. And we have the angles. Not the angle, but we have the index of refraction is going to be cosine inverse of what? And r is 1.42 divided by 2 times 1, because it's the index of refraction of air, times 1, and you will getting what? Theta r is equal to cosine inverse of 1.42 divided by 2, and if you do that, the angle is going to be 44.7, which is approximately 45 degrees. Haha, so the answer for this problem, the angles of refraction is what? 45 degrees. Here it is B. Yay. And actually, if you want to calculate how much is the angle of incident, well, it will be 45 divided by 2, 22.5. Yeah, okay. See you on the next problem. Okay, guys. Now let's look at this problem. This is number 7 from the review. This one says a ray in a glass is incident onto a water glass interface at an angle of incident equal to half critical angle for that interface. That's very important. The index of refraction of the water is 1.33 and water and air in the glass is 1.33 and 1.43 respectively. The angle that refracted ray in the water makes with the normal is closer to. Here we go. The first thing we need to know is these details is telling us that the angle of incident is equal to half of the angle critical. So writing that in expression, we have something like this. There we have it. First, that the angle of incident is half of critical angle. And in this case, remember, if we're using this expression for critical angle, we know that the index n1 is going to be bigger than n2 according to this equation we're going to solve in a second, which the equation says that the angle, critical angle, is equal to sine inverse of, I forget the minus sign here, of n2 divided by n1, which in this case, is we know the index of refractions that are given, is going to be sine inverse of n2, which is 1.33 divided by 1.43. And if you do this, the angle you're going to get here is 68.4 degrees. Perfect. Aha! But now we know the angle of incidence, because we know that the angle of incidence is half of the critical angle. So it's going to be what? 68.4 degrees divided by 2. And this is going to give us 34.2 degrees. But this is not the answer, because they're talking about the angle that is refracted. And we just found the angle of incidence, right? So now we use Snell's law again. Snell's law. And in this case, it will be incident, sine of the angle incident, is equal to angle refracted, sine of the angle refracted. And this is the angle we were looking for. We found the angle of incident, and that's the beauty, because if you remember the previous problem we did, we didn't know these two and we had to solve for one of them. But in this case, we solve for one of them because the problem says that a critical angle, the angle of incidence is equal, the angle of incidence is 1/2 the angle critical. We found the critical angle, we found the angle of incident, incident, and now what we're going to do is solve for the angle of refraction. So the first thing we're going to do, we're going to rewrite this equation. Let's write it this way, and r, let me write it here in a second. Well, we rewrite the equation here. We're solving for sine of theta r, which is going to be equal to ni divided by nr times sine of theta I, and then we apply sine inverse. Then we solve for theta r, and let's move this a little bit down, which is going to be Look at this one. This is the angle of, well, the incident. This is actually going from the media, which is glass, is higher, 1.43, divided by the other one. I think it was water. Water times sine of the angle, which we already found the angle incident, and the angle is going to be, and the angle is 37.2 degrees. Okay, try to look at this equation again. Look at this thing, guys, because remember the way I label this one, and since that usually incident is smaller than refraction, but in this case you have to read the problem because this is going on to, so in this case it's like going from glass to water, and that's why the index seems like a reverse. Take care, guys. See you next time.